Tell everybody, Josh. Secrets aren't fun unless you share with everyone.
Come on, Josh. It's a good secret.
It's a good secret. That doesn't make us want to not know.
In conclusion, what can we say about the drawing we just made? Well, one saying I can say for every single one of you is that there must be at least one point on your function where you can draw a tangent line that is horizontal. Every single one of you could pick a point, right, between your 2 points that will have a horizontal tangent.
Yeah.
Label that point right now.
I did.
Wait.
Mm-hmm.
The point that would be the horizontal.
So it would be an extrema between your 2 points. That's fine. You can label all three.
What else? Horizontal. Not the easy way.
That's
the
Any point then.
Sick.
Right? Like, use your knowledge.
That one.
So the activity we did earlier modeled MVT. The activity we're doing now models Rolle's theorem. What's the difference between MVT and Rolle's theorem then that you can kind of come up with? Rolle's theorem finds you something different than the mean value theorem. Perfect. They're still going to equal each other, but they're going to equal each other when the slope of the secant is 0. So that's the difference. Rolle's theorem finds when the slope of the secant and the slope of the tangent are 0. Mean value theorem says when the slope of the secant is the slope of the tangent. So they have a different purpose. One finds the horizontal tangents. The other finds 2 points where the slope of the secant is. So mean value theorem says average rate of change equals instantaneous rate of change. That's another way of saying it. When does the average rate of change equal the instantaneous rate of change? So the history of Rolle's theorem, where did this come from? Well, this came about in the 16th century. So some guy way back when imagined 2 points. Now he imagined his points, which you can use your coordinate to do the imagined points from him, on the x-axis. So he imagined his 2 points to be on the x-axis. And he imagined all the differentiable functions that could go through those 2 points. How many differentiable functions could go through 2 points on the x-axis? Yeah. Since our functions are differentiable, they are continuous. That's that rule of differentiability. If it is differentiable, therefore it is continuous. Are all continuous functions differentiable? No. Good. Okay, that was one of your questions on your quiz. By the way, it was both.
Wait, it was?
Yeah!
Okay, and their grass cannot have any holes or breaks. Hence the example you drew me, Josh, where it had holes and breaks. No goes. It also means their derivatives are defined everywhere, and their graphs cannot have any corners or vertical tangents. These graphs of all these functions have one property in common, that this Michael Rolle found in the 16th century. He noticed that every one of these functions has one or more points where the tangent line is horizontal, aka f prime of c equals 0. Rolle's theorem has 3 hypotheses that must be true in order to apply it. The first thing that has to be true is that your function must be continuous. The second thing that must be true is it must be differentiable on the open interval. Why does it not need to be differentiable at the endpoints? Yeah, so it also has to do with the fact that differentiability at an endpoint, we can't really take a derivative at an endpoint because we don't know what's happening from the left or from the right, depending on which endpoint you're looking at. So continuity are on the endpoints, they are closed. Differentiability is open on the endpoints. And the function has to have the same starting and end point. This is super duper important. If f of a does not equal f of b, nothing holds true. If f of a does not equal f of b, nothing holds true.
Wait, you said the same starting and ending point?
The y values have to be identical. Yes, this is the y values.
If you get like an x squared, can you just limit where you're looking at to use
that would be your closed interval. So you pick the interval to look at.
Okay.
So if it is x squared and we pick negative 2 to 2, we know negative 2 to 2 have the same y values.
So would any even function work? Because they're all locked on each other.
Yeah, eventually. Like, you may not have the same starting and end, because, like, they wouldn't be like that, x squared, because it could be shifted right, left, up, down.
Oh, I mean, if you just had x to the fourth.
Yeah.
Still shifting.
Because they're symmetric.
X squared can go off too.
As I said, as long as it's the parent function. Okay, therefore, if these three are true, then there is at least one point in that interval that we will call C, in which f prime of C equals 0. So what this is saying is there's one x value between A and B where the derivative will be 0. You have to write down what's in yellow.
That just means that there's an experiment. They're just guaranteed experiment. Or it's all horizontal. So like a Rolle level. That's an easy thing.
So it's nice because if an AP question asks you, is there a value f prime of C such that f prime of C is a root, or, I mean, an extrema, then you say, by Rolle's theorem, and you pick an A and a B to make it true.
Rolle's theorem.
Put a little tiny above the B so it's Rolle.
All right, let's show that that could be true for a function. We have f of x equals, mine aren't, they're not subscripted.
Yeah, it's okay. It's right on our paper.
3
Yeah,
x
that's right on
minus
the paper.
6x2.
Why? Okay, that is frustrating. All right.
This is
Actually, that's x to the negative second.
Okay, let's see if it satisfies. What has to be true? It has to be true that this is continuous. What type of function is this?
Cubic.
It's a cubic polynomial. Polynomial functions are all.
Pretty cool.
Okay, so what you have to do is you have to say, 1, f of x is continuous from 0 to 3. You don't have to say why, you just have to say that it is. Polynomial continuous functions are always differentiable. What's the last part that we need to prove?
Is there a reason you did? Oh, yeah, 0. Yeah.
Yeah, I need to prove that f of 0, which is what?
Which is
Negative 2.
What's that have to also equal? So f of 3 cubed is?
27.
Okay, so 27 minus 3 squared, which is 9. 9 times 6 is,
46.
so you have 27 minus 54 plus 9 times 3, which is minus
Negative 2.
27 and 27 become,
54.
yes.
Negative 15.
So step 3, f of A equals f of B.
True.
So, by Rolle's theorem, there exists an f of C.
By Rolle. Rolle. I'm putting the thing over the E just to make it fancy. By Rolle's. Oh,
You know what's weird?
Rolle.
I don't realize this lasts 2 periods. It doesn't feel like it.
Okay? By Rolle's theorem, there exists an f prime of C that equals 0 between the two of them. We need to find it.
no one else feel like having this classification period makes every other class really, really short?
No.
So, what is f prime of x? Yeah, so what is the
3x
derivative?
squared minus 12x plus 9.
Okay, so what do we have to do to this derivative to find that c value?
Plug in 0, 0.
No, they
Plug in
set it equal to 0, right?
Set it equal to 0.
Yeah.
And then change all the x's to c's. Because that's what we're... Because we want f prime of c, so this is f prime of c to equal 0, and we want to know what c is. So let's find the value of c, which makes the theorem true.
Wait, you can
Pull out 3.
factor.
Yeah, I would take out a 3.
Squared minus 4c plus 3.
So factors of 3, that's sum to negative 4.
Minus 1.
Therefore, c equals
3, 1. Jesus. Sweet baby Jesus. Do that.
if, let's say, one of those points was outside the interval, you would toss it out.
Who drew that circle?
How?
Talent.
Did you just? Hold on.
How much you look over?
Okay. So we already previously did the whiteboard example
We can do that.
doing MVT, right? I introduced it to you without you knowing what it was. I said, hey, let's do this activity. Draw me 2 points. Connect my 2 points on the slope of the secant. Now, what we're going to do is prove the mean value theorem, being given points and kind of walking through the process. So the mean value theorem means exactly what it has. It has the word mean in it. Go back to geometry. The mean in geometry was the average. So the mean value theorem is looking for the average rate of change. So geometrically, think of the mean value theorem as a tilted version of Rolle's theorem. So essentially what Rolle's theorem was is it had A and B as being horizontal. Now what we're doing is we're saying A and B don't have to be horizontal to each other. A can be here and B can be here. A can be there and B can be here. So do you see the tilted aspect to it? Okay. So both theorems conclude that there is a number c in between our interval, such that the slope of the tangent will be the same as the slope of the secant, which is the points being connected. The difference is that in Rolle's theorem, the height of f of A and f of B have to be the same. That is not the case for MVT. So the two ends of the graph of f don't have to be the same height for MVT. MVT essentially encompasses Rolle's theorem then. Because essentially if you could do it on Rolle's, you can do it with MVT. So if you forgot Rolle's theorem, you could apply MVT. It takes one more explanation. That's all. Okay. Looking at our graph, let's talk about what we know. So the line g of x is represented on your page. We know g of x is linear. Do you agree to that? The function meets with f of x at the endpoints g of a equaling f of a and g of b equaling f of b. So here's g of x. Here's f of x. And it's fair to say they start and end at the same point. Good so far? What's the slope of any linear function g? Go back to olden days. What would be the slope of g? If I asked you to tell me what's the slope of g. Okay, go ahead and fill that in on your paper. what would the derivative of a linear function then become?
Constant.
Okay, and what constant would it become?
B minus
Yeah, all over b minus a. Think about, yeah, think about,
Oh yeah, the slope is the
yeah, the slope is the derivative. Like as I was going to say, if I gave you y equals 2x plus 4, the derivative of that is 2. So the derivative of any linear function is always the slope of the line. Doesn't matter, what the slope is. Y equals 3/4 x minus 10. The derivative is 3/4. So g prime of x would be f of b minus f of a all over b minus a. Okay? We could write then an equation for g of x. Go ahead and do that. Think about what g of x is. So again, can you write the equation of any line in point slope form? We know its slope, and we know a point. So g of x minus, this is like my y1, equals the slope, x minus x1. You could have also had f of b and b there instead. Now we're looking at h of x. So change your focus from g of x to h of x. H of x is a
horizontal.
Horizontal.
Line. My
It's
bad.
like horizontal. A vertical line connecting two functions. So to find the distance between this, or to find the distance of that line segment, what would you do? This top point is,
F of x,
this bottom point is,
g of x,
therefore h of x is f of x minus.
g of x.
If f of x minus g of x represents h of x, what would h of a be?
F of a minus g of a.
Okay. And f of a equals g of a. So it's really like f of a minus f of a, which is 0. What would the derivative of h be then?
What's the derivative of h, you said?
Yeah.
Sure. There's no derivative.
Oh, yeah, 0.
Don't make it hard, right?
0
Like
constant, so 0.
h prime of x would equal,
F prime of x minus g prime of x.
that's what I said, don't make it hard.
Yes.
Does Rolle's theorem get applied? Yeah. Because f of a, g of a, now for h, we said that h of a minus It says, does Rolle's theorem apply? The answer is yes. Does the beginning and the end have the same starting values or y values?
Yes.
Yeah. So we can apply Rolle's theorem to H. So H prime of C would equal 0 for some value, right? Because some value of F prime of C minus G prime of C would equal 0. Because the derivatives would have to be equal. Is it fair to say that at some point the derivative of g of x will equal the derivative of f of x?
Sure.
I mean, can you see here if I found the tangent line of f of x, this would have the same slope as g of x? You're supposed to sketch that point.
Oh! There's a point. You mean on the graph top?
Mm-hmm. You could take a piece of paper and make them.
You can draw. That's difficult.
You can draw a circle here. You can draw a line.
No, I can't. I can't draw a straight line.
What would be true about the tangent line and the line g of x? Well, if you drew them nicely, g of x and this line here should be parallel. Once again, another visual representation of MVT. Everything about this lesson is very visual because you need to be able to see it to kind of know what it's asking you to represent. Once you can see it, you can apply it. So let's apply it to a function.
Cool. Succeed.
Okay? Let's look at the next example in your notes. What was just me talking? I'm a skill slide.
Still on backwards.
Okay. So we have f of x equals 5x squared minus 4x plus 3 on interval 1, 3. Mean value theorem is like rules. You have to have a differentiable closed function. Is this function differentiable?
Yeah.
Is it closed?
Yeah.
The given interval was what? Okay, so we have to say f of x is a closed, continuous function on 1, 3 and differentiable from 1 to 3. Next, you need to calculate the slope of the secant. So we need to find the slope of the secant, which is like calling it f prime of c. So we will say that we need to find the slope of our secant, and eventually what we're trying to do is set these two equal to each other. So what is the slope of the secant? The slope of the secant is f of b, where b is
3.
Because this is like so crucial. This is on the AP test every year. One of these problems. Not stress how important it is to think. Usually. Because you have to say by MVT, or IVT, or EVT, and justify why. Okay, the slope of the secant is f of 3 minus f of 1 all over 3 minus 1. So now I need to know what is f of 3. 9. 9 times 5. F of 1. So f of 3 and f of 1 do not have to be the same with MVT. So you have 36 minus 4 all over. So you get 36 minus 4, which is 32. 32 divided by 2, which is... So that's the slope of the secant. The slope of the secant has to equal what? So what do I need? Which is the derivative, instead of x's, it's c's. So 5 times 2 is 10 minus 4. So I need 10c minus 4 to equal 16. So again, I'm setting f prime of c equal to the slope of the secant. Solving for c. Oh my gosh, I'm so used to algebra 2. I was like showing all the lines. Does my c value live in my interval? You have to check that. If I got multiple c values and they were outside the interval, that wouldn't work.
Will you just discredit those?
Yes.
Or would you do something else?
Discredit them.
Just
Okay. What I want to do is another example with you involving I'll call it a real life scenario, but not really. Well, like this is applicable, but the scenario I made up didn't actually happen.
will I ever do this?
Maybe. We might have to fight this someday.
You're driving down the street, you need gas.
Intermediate
Theorem says you can make it to the gas station.
Intermediate value theorem says you're going to break down something
Oh,
this week
speeding.
now and
Yeah.
you run out of gas.
So
I
said you
was
need
right
to
with the
use
car.
Nope.
Let me tell you, whatever court of law, if they use the radar gun, they're not going to discredit it.
Mm,
No matter what you
those
do.
can be false.
I know.
Yeah.
but No court of law is going to be that guy.
Now you can bring your couch.
What is it?
Speed
Last
trap.
summer,
They'll probably call me a nerd and then give me the fine.
Last summer, Miss M was traveling on the Dewey Thruway,
They double your fine.
which was a 65 mile per hour speed limit. God,
That's
that's like
what
that.
I'm getting
This
at.
isn't true.
She was going to get
After, I've never gotten a ticket. After she passed through the second toll booth, she was pulled over.
Gets the tickets.
I know, I would cry.
Just because you didn't get one. doesn't
After
mean
she
you
passed through the second toll booth, she was pulled over. The officer told her that she had covered 144 miles between both booths in 2 hours.
How does he know?
When you go through with like your Easy Pass and you get the tickets out of the toll booth machines, they do track your speed. So like, if you don't like pull over or go to a rest stop, then like it knows what time you started and what time you end. So like if you have an Easy Pass, they know exactly who you are. They can send you a ticket. Just you got a ticket. I've known somebody that got like a ticket. Certain red lights they take the cameras. They take the pictures. So like they'll take a picture of your face and your license. And like my mom got me a license, but her brother was driving her car, so it was his face, her license. So like he got the ticket on her. But she had to like prove it wasn't her because of the front picture. But in the meantime, yes, easy booths, like the Easy Passes and the toll booths all record your speeds.
What happens if you have a twin?
You can't speed.
Oh,
What if like you're trying to airport?
Yeah, what if it wasn't you driving your car?
that's what I said happened to my mom.
What if it's
Yeah, but
brother.
Easy Passes don't take face pictures, do they?
Yeah.
They just look at the license plate.
No, they have face pictures too.
Oh, well,
Next thing
that's
you know,
what
someone steals your car wearing a baseball cap, goes 100 miles an hour.
I think it's pretty obvious when they take the face picture.
I'm just gonna start wearing baseball
Okay.
caps and claim
No, I
this
mean like
over.
wear a baseball cap.
Oh, baseball cap.
Or
Okay,
like
using
Eskimo.
the mean value theorem given below, discuss how it will support the officer's argument that Ms. M was speeding.
Also, the officers that are here.
She should have only gone 130 to ours.
Okay,
Hey, she's
so
about
that's
5
part
minutes.
A, right?
15.
She's only like 7.
No, like,
What?
so the average rate of change, or the average speed she was driving was what? What's her average rate of change? Yeah. 72 miles per hour, right?
7.5
And since the
miles.
distance traveled over the time period is a continuous differentiable function, MVT guarantees at least one instant where her speed was 72 miles per hour. Therefore, at least at one point in her journey, was she speeding?
7 miles over.
So that would
Dude, must be out of
be your argument.
That's like 2
He has to meet, he has to meet that,
You're confused?
Yeah.
Okay, so she traveled 144 miles in 2 hours.
Yeah, but like, how, did we even do anything with A, B, C, D, then?
No, that's a different function. That's a different example.
It is?
Yeah. We were literally just answering the why question mark at the top.
Okay.
We have not gone beyond the why.
Okay. I was confused.
No. The next part is example 1. Like she asked if we were doing anything with
Oh.
example 1 yet, and I said we haven't touched example 1. So, example 1 is graphed for you. It is a quadratic function, shifted right 3 units and up 1. So it also has 2 lines drawn in it. One is the secant, one is a tangent. Could you label the secant and the tangent, knowing what you know now? Look at the graph given to you on the page. That is a quadratic function shifted right 3 up 1. Could you label the secant and the tangent? Which one's on top? Good. Now the questions follow below. What's the average rate of change from 2 to 5? You're still stuck on that.
Well, I guess.
What would you like I-79 is 55. I can tell you not a single car is even remotely close to 65.
I love when I was on.
79 up here is 55.
Exactly.
on a
And
road.
everybody's doing at least 70.
I do.
I was on a
You know
road
where
that
the cops are, you're good.
Chartiers run, or before Chartiers run, where it's like 25 there. I was going like 45. A cop. Because I know I was going exactly 25 because there was a cop there, and I was like, okay, so I go speed limit. The cop, yoink.
Okay, find f of 5 and f of 2. So that's part A. Find f of 5 and f of 2. Find the average rate of change, aka the slope of the secant. We say for short average rate of change. You'll start to hear it called AROC, or average rate of change. So at the NIMSY session, they may call it AROC instead of saying average rate of change or slope of the secant. So the AROC would be 5 minus 2 over 5 minus 2. Yeah, that's annoying.
Why is that a ton? Wait, is that part B or? That's part A?
Yeah, that's part A.
So that's 1.
Okay, part B, explain why this satisfies MVT. So how could we say that this satisfies MVT? It's continuous. differentiable. It's a closed interval.
1, 2, 3. Oh wait, no, it's not.
It's just saying the slope has to be 1 between 2 and 5. Let's apply MVT. What does the application of MVT guarantee me for this particular example? F prime of C has to equal what? Yeah. F prime of C must equal 1. That's what MVT guarantees. What is C? So what do I need?
You said derivative equal to 1.
Okay, so what's the derivative of F?
2 times the derivative of x minus 3 5.
It's 2x minus 6.
Yeah, 2 times 20 x minus 3 or 2x minus 6.
Yep.
2x equals 7. X equals 3. 5.
You don't want to know.
Is 3.5 between 2 and 5? If you look back at that graph, does the line they drew in look like it's at about 3.5 for your x value?
Yes.
There you go.
It's pretty darn good.
So you're going to do some problems in your book, and then finish the example 2 on here. So I want you to do the example on the back, and then some book work.
That is hard.